All right, so first thing I want to talk about is, actually, I don't even need that today. First thing I want to talk about is midpoint formula. So, you know what? Well, I'll stand. So midpoint formula. Who can tell me what the midpoint formula is? And what I'm saying is, who can tell me what a formula is to find the point in between two other points? Anybody know it? The what?
The x's added up over 2 and the y's.
So the average of the x's is the average of the y's? Okay, so if I have 2 points, I'm just going to call them point 1. We'll call it, I don't know, x1, comma, y1. And I have point 2, and we'll call it x2, comma, y2. Then the midpoint of point 1 and point 2 is the point where you average the x coordinates and you average the y coordinates. Where you average the x's and you average the y's. So maybe a better way of saying that would be to say something like the x coordinate of the midpoint is the average of the two others, and the y coordinate of the midpoint, is the average of the x's, and the y coordinate is the average of the y's. Now, why do I like this a little bit better than this? Because what if you know the midpoint and one point, and I ask you for the other? Then if you have a formula, you can just plug in what you know. So here's what I'm talking about here. So let's just say I gave you, let's just say I said point 1 is -3, +12. Point 2 is +15, 32. And I ask you, what is the actual midpoint of these? And all you would have to do is say, well, the x coordinate of the midpoint, all I have to do is average the x's. And you know to average, you just add them and divide by 2. So that gives me 12 over 2, which is 6. The y coordinate of the midpoint, I'm going to average the y's. And if I get a fraction, no big deal, all right? 44 over 2 is 22. So my midpoint is 622. And you'll do this all the time in geometry and math or trigonometry, things like that. Have y'all done that before? You knew what to do so clearly, I guess. Now, what if I said this? What if I told you, hey, there's this point out there. And I would probably word this. Say you know a point, but you also know the midpoint of P1 and P2 is, and I gave you that, and I told you it was something like, I don't know, 11, 30. So if I have a point and the midpoint, and I say, what is point 2? What is that other point? If you wanted, you could still just use your formula. The only difference is this time I know the midpoint, right? And I know one point, and I know right now somebody's brain's going, man, there's an easier way to do this. I would agree. And you could just use algebra to solve, right? You could multiply both sides by a 2, add a 3, right? Multiply both sides by a 2, subtract the 12. So it turns out my other point, point 2, is 25, 48. Now, with these three things in mind, I want you to notice something. If anybody notice something also that you could do? Yeah.
Subtract the midpoint from the other point, or like subtract the x and y's and find how much it goes up and how much it goes right.
Okay, so he's thinking great, but he said subtract the midpoint from this. I would probably take the midpoint and subtract that, right? So if I'm in the middle, I'm going to go, well, what's 11 minus that -3? 11 plus 3, which is 14. So that means I basically increased 14, right? Well, increase another 14. Because if you think about it, if I have a point right here, and then I have another point that's a midpoint, and there's another point over here that makes that the midpoint, aren't I going to rise the same thing here and run the same thing I'm going to rise and run here? So if I find the change in x, that's like finding how much I moved over there. Well, that's how much I'm going to add to the midpoint to get to this. So if I increase that by 14, add another 14. And then if I look at this, what's 30 minus 12? 18, which means if I go up 18, I'm going to go up another 18. So I think that's probably the easiest way to go. And then if you're unsure that you made a careless error, check it with the midpoint. What's the average of -3 and 25? 22 halves. What's the average of 12 and 48? 60 halves. So it's really easy to check. But the downside of doing that in your head is there's probably not any math going on, is there? So there's just an answer. So if either one is wrong, it's like, if that's wrong, slash. If that's wrong, slash. Whereas here, if you made a careless error, I'd go, oh, well, they know what they're doing, but they forgot of something or whatever, ... Might cost you a little less, but most people do really well with this kind of question. Y'all seeing that? Okay. And they can eyeball those, and it's just a lot less writing. All right, what about distance formula? Anybody remember what distance formula is? So you're saying distance formula is, I'm going to put a D right here. Distance is you said square root of?
No. It's x2 minus y.
That would be x2 minus x.
No, it's
x2 minus x1? What about it?
And then you split.
Square
And y2 minus y1.
plus y2 minus y1? Now here's the really critical answer. Why? I mean, clearly some of you forgot it. So the memorizing, even though you're going to get it refreshed today, might come back to you, but what am I really doing here?
Pythagorean theorem.
Pythagorean theorem. Now, if you didn't know that, that's actually a really good response. Normally, I have like crickets and then maybe one person. Kind of heard like a little chorus there, which is nice. But look, if I have 2 points, first one, x1, y1, right? Second one, x2, y2. And I'm just going to draw those randomly. Like, let's just pretend that's point 1. So here's your x1, comma, y1. And then let's just say that's point 2. That's your x2, comma, y2, right? If I want the distance right here between them, couldn't I think like, well, if I could figure out that length, and I could figure out that length, then that length is kind of like in the Pythagorean theorem, it's kind of like A, B, C, right? Wouldn't it be kind of like, hey, d squared equals that length A squared plus B squared? Wouldn't it basically be that? And if I square rooted it, wouldn't it be D equals the square root of that A squared plus B squared? So the question is, how do I find A? Well, if I know this is the x coordinate of that, which it is, right? Like if I were to draw that x value, doesn't it come down and hit like the x-axis right there, or maybe go up and hit right there? So if I know where that is, and I know where that is, can't I just go x2 minus x1 to find that length? So the A is that, and isn't the B how high you are here minus how high I am there? And aren't those the y coordinates? So the B is just y2 minus y1 squared. And if I do that replacement, there's my distance formula. So I hope you don't forget it. Every now and then I have somebody that does. Just like I told you, there's that guy. There's always going to be somebody who misses domain. We had one.
In this class?
Yep.
Ooh.
Now, in their defense, they actually did the range incorrectly. What they wrote for the range was the domain, and what they wrote for the domain was the range. So they kind of knew what they were doing, but maybe they memorized the terms backwards. So, but it was almost perfect. But I did have one person. I won't say any names. You might not even remember because you might have accidentally done it backwards. Anyway, but otherwise, pretty good. All right. So if I ask you for distance, it shouldn't be a big deal. Like if I said, hey, what is the distance? What is the distance? And I said between -2, 7 and 12, -8. So you don't need to draw a picture. Don't do that. What do? Well, the distance is the square root of. Oh, and by the way, I realize when you square root both sides, you get a plus or minus there. Why don't I put plus or minus? Because it's
always plus.
distance, right? It's always a length, so it's a positive value. That's why. So what do I do here? So I got to go x minus x squared. Now, if you want to go y minus y squared, that's fine, because you're still getting that and adding it to that. So the order doesn't matter. Also, can I go x1 minus x2?
Yes.
Why? Because I'm squaring to make it positive anyway. Now, it's good form, I think, to go 2 minus 1, 2 minus 1. But again, your math's going to be the same. So who even knows what the first and second x is, right? So if I went 12 minus that, I like putting minus a -2 in there and then squaring it. So when I go 12 minus a -2, that gives me a what? 14. And then when I square 14, I get, so I got a 196 in there right now. And then for the next one, I'm going to go what? -8 minus this 7. What's a -8 minus a 7 squared? -15 squared, which is 225. And then you get this thing, you get what? 421 under the radical. And I know a 3 comes out of that. I mean, a 9 is in there, right? So 9, I guess, goes in there, what? 4 d8. 36. No. 9 doesn't go into that.
Yeah, because it adds up to.
I'm like 4 and 2 is 8 plus 1 is 9. Okay, so no, I don't know if that even simplifies. And you're not going to have stuff that's big and nasty, whatever. So for all practical purposes, that's good. You good? Now, here's the question I have for you now. What if I said the distance between, what if I said this? Find the point or points that have a distance of 10 from this point. I'm going to clean that up in a second. So this point, 2, -6. Find the point or points that have a distance of 10 from that point. What are you looking for? Now, there are 4 points that go straight up, straight down, straight left, and straight right. Getting closer. Do what? Actually, not a circle. Even though we're talking about circles. Why isn't it not a circle? Why isn't it a sphere? Oh. If I have a point, can I go in every direction? Isn't there some ball out there that has a point in the middle and the edges of the ball are 10 units away? So what would make this a circle? Find all the points in the plane that are a distance of 10. Now, if you really think about the math of this, the points in the plane that are a distance of 10 from that make a circle, right? I mean, there's some point that's over here at 2, -6, that if I go up 10, down 10, right 10, left 10, and I get out my Homer's-esque ability to draw circles. I actually have a nice video on this. I usually do a better job of that, but I'm trying to sketch for you. But nothing in. I did have a circle off with him once in front of people. It was after school. Somebody goes, "Hey, y'all do circles." And out of just randomly, I just was like, perfect circle. And he was like, "Oh no!" And he kind of panicked. But normally, I mean, you've been in class, so normally it's like, It's like he's a freaking compass or something. Anyway, the point is right here, if you think about the distance formula, and I'm plugging everything in, distance, no, do not freeze it. Okay, look, distance 10 is the square root of, and what's the formula say? X minus the x, x1 minus x2 squared, and then y1 minus y2, which makes that positive, squared. What would happen if I squared both sides? Wouldn't I get 100 equals this? And most people don't write it this way. Most people write it like an actual circle like this. They'll say x minus 2 squared, y plus 6 squared, and they'll put the 100 on the right side. That's circle form. Your form of a circle is built from the distance form. Actually, the distance form is built from a circle, but the circle form in some ways kind of looks like it's coming from the distance formula. But the bottom, which is the Pythagorean theorem, but that's what a circle is. And you'll see this in your notes in a couple. Why don't we just go to our notes? You'll see this in your notes right here, circles. There's your formula. So if you know your center, and notice I'm using HK for the center, just like I used HK for the vertex. If you know your center, that's the point you know, and you know the distance from the center to the circle, which is the radius, you'll notice, look, there's the radius squared. There's your center right there, HK. Now you do have to change the signs like when I put it in there because it's x minus, and you have to change the signs when you come out, kind of like you did with the vertex. And then you already know area is pi r squared. You know pretty much everything you need to know about actually graphing a circle or whatever. But that's what you get right there, just the area. I mean, there's a formula for a circle. And it's basically the Pythagorean theorem, except with variables in different places. There's your like a squared, b squared, c squared. So hopefully, if I give you an equation like, I'll talk about completing the square in a second. If I give you an equation like this, you'll go, oh, well, the center is at positive 5, negative 2. If I want the radius, what does 16 stand for? The radius squared. So square root it, and I get 4. And if I want the area, it's just pi r squared. So pi times the 16 pi. Now, what if they put it in this form? Can you tell everything you need to know about whether that's a circle or whatever it is? I can't tell anything from that, can I? But what has to happen in the end here? Have you noticed on the circle? What's that number right there and right there? They're both ones right there. So what that means, and there's nothing in the denominator, right? There's nothing there. You could argue ones also. So if I see something right here, you're going to notice that I'm going to scroll down one, look. And that, I'm going to scroll down again, way down. And that, and even that, they all look similar. You can't see them all at once now, but if you looked at them all together, they're very similar. But when you look at them, there is a way you can kind of tell right from the start whether it's a circle or at least has a shot of being a circle. And if you ever forget these rules, scroll down and it'll say, how can you tell if an equation is a circle before you complete the square? Well, both variables have to be squared somewhere in the problem. If only one is squared, what do you know that is? You already know this. It's a parabola. And you saw those, right? When you wrote out the parabola, you'd have like y's and then x squareds. Now you're going to learn you could possibly have x's and y squareds as well. But both the things were not squared. So the first thing you do is you check, all right, are they both squared? If they are, can't be a parabola. But it can still be a hyperbola, ellipse, or circle. So the second thing you check is, are the x squared and the y squareds, do they have the exact same coefficients and signs? So when I look up here, I go, yeah, positive 3, positive 3. Who cares about the rest? If the x squared and sine squareds have have the same sign and the same number, then it's going to be a circle, or it's going to be nothing, or it's going to be degenerate. We'll talk about those later. So what do? You complete the square. But you complete the square with this in mind. Unlike a parabola that has like y's on one side and x's on the other, what happens with the circle? Both my things are on the same side, right? Just the constants are on the right side. So you're actually going to complete the square twice most of the time. So here's what you do. You see that? And you think, all right, I'm going to put all my x squareds together. So I'm going to take, actually, you can divide by 3 if you want. You don't have to do that, but you can. Sometimes that makes fractions. So sometimes people don't like that. But look, I divided by 3 here because the 3 divided in nicely. Why not, right? So then I took all of my x's and put my x's together right here. I took all of my y's and put my y's together. Notice I left a little space to complete the square, and I moved the constant to the other side. Now, if I did factor out the 3 out of both, then I leave it for now, and in the very end, I divide it out. But since it divided out nicely here, I did it. You'll get a little practice with this. And then look, completing the square just like you did before, but you got to do it twice. Half of 10 is 5. Square it's 25. Add it to the other side. Half of 4 is 2. Square it's 4. Add it to the other side. Factors the same way, right? Square root, sign of the middle, squared. Right here. Right here, square root of that, square root of that, square root of that, sign of the middle, squared. And then you're left with just that, and that, which gives you a 16. And you got it completed. And once you have that, you can tell where the center is and what the radius is and find the area and do anything you want. Are you with me? Now, let me just caution you. Just because it looks like a circle at the beginning doesn't mean it has to be a circle. And this is why. The reason why we call these conic sections is because they are slices of a cone. They're actually slices of a double napped cone. A double napped cone is this. Let me write it out. A double, I think it's napped, G-N-A-P-P-E-D, cone. All right, silent G. A double napped cone is actually a cone on top of a cone. It almost looks kind of like an hourglass. All right, I only have one cone here, but whatever. All right, it'd be really hard to have it connected or whatever. So, and more expensive. And this one actually was, somebody made it on a 3D printer for me, Michael Mormon. But then this piece fell on the floor and the cleaning ladies threw it away. Anyway, whatever. So slices through this cone make conic sections because these are sections of the cone. All right, so think about this as having an axis right through the middle, all right? Vertical axis right through the middle. If I make a slice that's parallel, it's perpendicular to the axis, what do you think it makes? That's a circle. That's a conic section, okay? That's the first one. Now, if I make that slice slightly slanted so it goes in one side and out the other, what do you think it makes? An ellipse. Very good. Now, what if I make that slice parallel to the side? Then it goes in one side, but it never comes out the other because it's parallel to this, right? Just keeps going down forever. And by the way, these cones keep going down and keep going up forever. Guess what that makes? A parabola. You can see that on both of those. Now, this one actually is not accurate. I mean, it is technically a hyperbola, but it's the ones we do, it should be perfectly vertical. This one's still got a little tilt. But if it's not parallel to the side, but it's a slice like a parabola, but because it's not parallel, it's tilted a little bit more, then it's actually going to go through the bottom part and the top part, isn't it? Because if it's like that, and all of our slices like that would be vertical. I mean, parallel to the axis this time. If it goes to the top and the bottom, then you see this little part on the bottom, and you also see a part like that on the top, and that makes a hyperbola. But sometimes the slices go awry, okay? So think about it like this. We already just said if I make a slice directly right here, perpendicular to this little axis that runs through the middle, that slice makes a what? It looks like an oval there, but only because I'm doing it in 2 dimensions, right? So that's a circle. What if I made the slice, though, right at the tip? Point. Now, a point is infinitely small, right? I mean, we draw it on our paper, but it actually almost looks like a circle. It has area when I draw it. But it's meant just a singular location, right? So how would that look? How would I get just a point? Think circle with a radius of nothing. So if in the process of completing the square, like what if I had started with, instead of 39, what if I had started you with, how about 29, right? So if that had been a 29, what would I have done? I would have subtracted 29, right? And when I subtracted 29, I'd bring it down. And then I would have completed the square and got that. What do I end up with? 0. That means that this ends up not being a circle at all because the radius is nothing. It ends up being that little dot. We call slices that end up going through that little bitty tip degenerate conics. Okay, so something like that would be a degenerate circle. And a degenerate circle is just a what? It's just the point. It's almost like the center. That's a degenerate circle. And there are degenerates of all the conics. Although it's really hard to create a degenerate parabola because a degenerate parabola looks like a line. And if I were to go, hey, what is this? You would probably go, oh, that's a line. And I'm going, no, degenerate parabola. That's not going to happen for you. But technically, it would be hard to tell. But a lot of people look at this and they go, oh, yeah, these are the same. And they're both squared. Must be a circle. Well, you think it's a circle, but there's a chance when you complete the square, if you get 0, degenerate circle. Now, what would happen if this happened? What if instead of having, come on. What if I didn't have 29 right there? Oh, it's over here. What if I instead had 39? No. What if instead I had 19? No. 49. Sorry. If I had 49 there, 49, negative 49, negative 49, then what happens? What do I end up with here? Negative 20? What the heck does that mean if this ends up being a negative 20? It means there isn't a circle. There's nothing. I mean, think about it. How do I square something? What is that going to end up being? Or 0. What happens when I square that? Or 0. So what's the biggest this could possibly be? Well, no, I'm sorry. The smallest it could possibly be is 0. Biggest could be anything. But the point is, could it ever equal a negative 20 and be real and graphable? No. So if that happened and you got a negative over there, now I don't mean if you start with a negative. I mean after everything, when it's all said and done, if you got that, you'd say, oh, this doesn't even exist. But interestingly enough, a hyperbola where you end up with a negative does exist. You just got to manipulate and make it work for you. But it wouldn't exist for circles or ellipses. And then parabolas are totally different from this. Are y'all following with me? Okay. And then what I also want you to know is circles are to ellipses as squares are to rectangles. Squares have all the properties of a rectangle with the exception of the sides are all equal. But all the other things are the same, right? Parallel sides, right angles. Well, circles are kind of like that with ellipses. Ellipses have foci and all kinds of stuff we'll talk about. But a special case when the foci come together in the center, if they start overlapping, it turns into a circle. But they kind of look similar. I even sometimes give a trick question where it's set up like an ellipse. But you look at it and you're like, ooh, wait a minute. That's a circle. And it's sometimes a bonus question or whatever. But anyway, that's everything you probably need to know about circles. I'm going to give you different questions about it to kind of mess with you, see what you know. But that's kind of where we are. Oh, one last thing. What if I gave you something like, and I always say one last thing like at least 6 or 7 times a day, but like right here, what if I had given you x minus 1 squared plus y minus 2 squared equals 12? Now, what's my vertex? I'm sorry, what is my center? 1, 2, right? This gives me the x, that gives me the y, because x and y. 1, 2. So I would go right here, right? Now, what's my radius?
The square.
My radius is the square root of that, right? So if I was writing it out, I would write 2 root 3 like I heard from the back, right? 2 root 3. But what if I'm graphing it? I mean, what the heck does root 12 mean? Well, how would you think? 3-ish. Why? Because root 16 is 4 and root 9 is 3. So it stands to reason that root 12 would be somewhere in the middle. Maybe it looks pretty close to the middle, right? But maybe a little bit leaning towards the 9. So maybe, I don't know, 3.4-ish. Am I going to notice the difference when you're sketching it? So when you go to graph it from here, you're going to go, all right, 1, 2, 3.4-ish, 1, 2, 3.4-ish, 1, 2, 3.4-ish, 1, 2, 3.4-ish. And that's going to be hard to go this way, 3.4. So you're going to have to draw as good of a circle as you can possibly draw, right? So my advice to you, for those of you that I always have somebody, they always start strong. It's kind of like, all right, got my circle going. And then eventually it turns into this weird baseball diamond looking thing. So if you struggle artistically, which listen, man, I had these 2 kids named the Vaughn brothers. They were like 3 or 4 years apart. Brilliant kids. One went to Duke, one went to Stanford. Worst handwriting I've ever seen in my life. And I got a girl as a senior this year whose handwriting is atrocious. Probably smartest girl in class. I mean atrocious. Like nobody in here really stands out to me to have so atrocious a writing. But like Jimmy Vaughn, this was a 6.
Did they happen to become doctors?
I haven't heard from him since I left, actually.
So it makes sense.
But here's a 6 for Jimmy. Here's a 9. Here's a 4. I mean, they like, yeah, I know, like how clever. Every number's the same, but they all look the same. That's kind of creepy. They're 6s. Anyway, like every number kind of seemed the same. So fortunately, he was smart, and I could give him the benefit of the doubt. But like, we'll talk about Vaughn's again when we get to sine curves. But here's my advice: if you stink at sketching, do this. Put like a little bitty mini parentheses at these spots, and just kind of like little parentheses right there, and it'll kind of get you going, right? Kind of already start the curve a little bit. It kind of helps a little bit. I mean, you still might be a little flat on an edge or something like that, but again, I'm not grading you. Just stay away from the diamond or the square, whatever square. But make sure you have a vision for like, just make sure it's between 3 and 4, and I'm happy if that's between 3 and 4. But if I ask you to write out the value, of course, always simplify everything. Don't write root 12, write 2 root 3. Y'all with me? And I won't ever give you a picture in the red and say, well, what's the radius? Where you're like, I don't know, is it 3.3, whatever? You'll see right here, it'll always be a whole number if I ask you to go from a drawing to a graph. Are you with me? Try to think if I'm forgetting anything. I don't think I am. All right, so I think I gave you bookwork tonight. Okay, and there's gonna be a lot of little worksheets moving forward because I think my stuff's better than theirs. Like here, I've got classwork and junk like that for parabolas, which we should know. Most parabolas we're learning a little bit new tomorrow, but most of it we already knew. All right, what do we got? How much time?
5 minutes.
5 minutes.
Grade test in 5 minutes. Speed grade.
Can I do what?
Grade 5.
Can I give you your review? You want that back? I'll give it back eventually. Let me enter your grades real quickly in Schoology, not Schoology, whatever it's called.
I'd be happy.
Imagine putting it indoor sports.
All right, they're all in there, although there's somebody who has above 100 and I don't have it set up. It's going to take a second. So if you're showing 100, then I'm going to fix it so I can get your. So there's hope you may have more.
Oh, that's the 3 out of 0.
No, well, because there were bonus points at the end. All right, now everything's in there, and you can look.
Yeah, but that's oh yeah, I'm just gonna say that. You got
My phone's dying.
Yeah, give me 2 seconds.
I got it.
Oh, that's why you're asking. Okay, yeah. No. I know. I'm sorry. I didn't process that. Okay.
It's only gonna be 34. What?
Okay, here's something that might be. Did you happen to do anything weird to your review? It's not normal. Like attach something to it? Yeah, you would. This is very easy. Well, it's not with that period. Is that you? Did you do this? Yeah, okay, you turned it into 6 periods. So I'll fix it.
Are we just gonna go and try to do
Can I see what I can't get on?
I got a 9. Oh man, I lost to an 8.
I was like going back and forth because I
Yeah, then it would change.
Wait, were you
Well, I'm pretty merciful. So you always get half credit for a day late. Normally, if it's not a habit, I normally just get full credit. But is it in there now? Let's have a look over there.
Also, do you know anyone?
Yeah, me. I'm here every morning after school. If you want to pay somebody $60 an hour, you can. And you might really want that. But I would start like this. Truly, people that do this save a lot of money for their parents. You're here, y'all do pay attention in your class. But I get the feeling sometimes homework is kind of like, when I do it, I'm looking online and kind of copying down for Schoology or maybe filling in the blanks. You're not really learning. Part of learning is suffering sometimes and failing at a problem only to learn from those mistakes. If you really maximize that homework, like literally go home, do every problem, then look at Schoology, or at the minimum, do it on your own, then check it. But don't have them open at the same time. That's kind of like, it's like if I'm lifting weights and somebody's helping me a little, I don't know if I can do it or not. And that's what's happening. So do it on your own, check it when you miss it, crap, try to figure it out, and then redo it and leave a trail of crumbs for yourself. So a night or two before the test, you go back and you look, and every one you missed, redo them again. You guys are smart enough. You won't be making. At the minimum, you'll be making an B's and A's, I would think. I mean, you're just smart enough to do it. I don't. Both of you. I see these flashes. I only think the thing that may hold you back sometimes is the fact that you're just not really learning from your homework like some other people are. That's the major difference. It's not like you're sleeping.
Well, I was sorry about that.
I didn't even notice.
I get caffeine now, so I don't know.
And I was like, you're putting yourself away.
Oh.
Okay, we're all honest here. No, and I was listen. I fell asleep too. I get it. I was human. But try, if you really maximize your productivity and homework, you're going to see a difference. Yeah, I really do. And you'll save your parents 60 an hour. Whatever. See you guys.
Common letter. Yeah. I know. It's probably already been decided. Well, I'm a little distracted during.
So, Abby, you're a big tennis player?
Yeah.
Yeah? What seed are you on your team?
5.
5?
That's right now.
I played a lot of tennis back in my day. I got so competitive, I don't even play anymore. Like, I can't have fun. Like people who play tennis for leisure, I'm like, no, I just want to kill somebody when I play. It's hard to just enjoy it. Like if you're keeping score, then you play to win. So I haven't played in years,
I play with my family.
but I loved it when I played.
Yeah, I like his lessons picked up like this. Like how genuine.
Okay.
No, and then when he puts his
What is
pride.
the all in?
I do that sometimes.
You're not even a
When who loses?
When my little brother loses like anything, he'll lose Monopoly and he'll start crying.
Yeah, I had a problem too.
You cried?
No, I would just get angry. Like I was way too competitive. It became a problem. I had to kind of learn to step back a little bit. But for a while there, it was like, I mean, I'll die on a sword to win. I'll figure out a way.
Elliot, nobody does.
It was not healthy.
My cousin.
They're like,
That's not understandable.
yeah.
Is it?
Ben Shapiro was
I truly have never even heard a discussion on Ben Shapiro's hotness ever.
Who is that?
He's this like phenomenal debater. He's super logical. Like I don't know if you can out debate him. I don't know if you can. Like you may not agree with him, but he uses logic. I think he might be on the spectrum in some ways, but he's unbelievable what he has in his head. And the way he can go from A to Z logically is just this guy named Ben Shapiro. It is shocking. He'll destroy people in debates. Like you got to come equipped, and he'll give you credit if you have a good argument. And heck, he might not even, he might pull stuff out of his, I mean, he might be making up some stuff, but I don't think so. You've ever seen Rain Man?
That's like.
Yeah.
He strikes me a little bit, kind of like he's got a little bit of a, not really, because he's super highly functional. But it's just not normal how good a debater he is. But there are all kinds of video clips you can find on him, whether you agree with him or not, because he's very political. He has a lot of political arguments, so you probably love him or hate him. But in terms of his debating skills, like you come in there weak and not prepared, you're getting destroyed. I mean, he'll just crush you.
Well, now the sex
All right, guys, I would love to be able to give you your grades, but I am 2 papers shy. I literally graded from 8:50 in the morning all the way through to 8. And then I had to watch the Auburn game. But at halftime, we were up by 20-something. So at that point, I started just mostly grading until 10:15. And I still didn't get done with your class or the other class, but I've gotten all but these last 2 done. So I'm done 7th period. I'll grade these last 2. I'll get them in. Or if we're done before the bell rings, I'll quickly grade it because we were in the last class. I'll grade the last 2 and post them. And then so at least you'll see your grade. And if I can't grade the last 2, I bet I can at least post the ones. I have all but Jack's and Ben's. But I can at least get the ones I have graded in. And you can see what you have. And then we can go over it tomorrow. All right. I'll keep the other half. Cut it off with some scissors. There's some scissors up here for you, man. Make sure your name's at the top of that thing. And then keep the other side so you remember the dates. Just any of these. All right. Yeah, if you did not give me your permission slip yesterday, make sure you give it to me today. There were like 2 or 3 of you guys, I think. And then we'll all right. So guys, today we're starting something. Hold on.